Hi, welcome to another Coatings and Coffee video with myself, Richard Jennings. We've got our very knowledgeable and lovely friend here, Mr. Kees den Hollander. Hi, Kees, how are you?
Hello, everyone. I'm doing well. Hope you do as well. Happy to be here again, Rich.
Good. So, my usual thing, Mr. den Hollander, what do you have in store for us today?
What we have in store today, I think quite an interesting one, and I think a lot of people are interested in this, especially considering all the environmental challenging conditions we faced the past months. I think it's a good time to look back at that and talk a bit more on our reducers. We have multiple reducers in the assortment, like the T2, the T3, T1, T5, T6, T31. But Rich, I reckon they all fit a certain purpose, or can we maybe mix them up together as well?
Yeah, good question.
Please enlighten us.
Oh, so it's down to me again, right? So yeah, you're right. Every solvent reducer has a different job to do. If you think, so this is education, right? This isn't just about AkzoNobel's products, but we're going to use those as an example. It's education in paint and how you might use it. But if you think, certainly in our range, we've got T6, which would be our epoxy reducer. That's the one that you use in the primers, those sort of things. We have other specific epoxy primers, T0073. People are going to quote me on my numbers. I just call it T73, but that's another one in Ultra Build. And then we're going to, there's cleaning ones. There's T8. That's almost like a pure alcohol. That's a good one for cleaning, and particularly if you've got or you're concerned about moisture on the surface. You may have washed the boat down or be unsure if you've got rid of all of the moisture on there. Using an alcohol type of wipe is a really good idea. So a T8 wash prior to your normal clean down regime is quite a good idea. But I guess, and I'm reading between the lines, I'm looking at your face there, I'm guessing you're talking top coats, right? That's probably the one that you're,
especially challenging kind of conditions like low temperatures, low relative humidity, or even high temperatures.
Yeah. So we have a choice, I guess. I mean, some of you have been watching these. You know, I'm old now, so in my day there weren't so many solvents. Old and bold. In my day, there wasn't so many solvents, and people used to add more solvent, reduce down the paint to get it to flow better, to look great. They used to heat the paint. There was all of these different tricks that they did in the day, but actually, what we have now are a choice of solvents to be able to give us the best out of the product, and that means we can sometimes blend as well. So let's just look at the top coat range. So I'm going to put one out there first. The 31, that is a brushing reducer, really slow. And what do I mean by slow? I mean it holds the paint open for a long time. It allows post flow, allows the paint to flow out and level and look really good. So if you think, why do we want that? Well, when you're brushing, you've got brush marks in there, and you want to lose those. You want them to flow away to nothing. So T31, that's one that's out there. But then in the spray range, and correct me if I miss any or I get any wrong, I'm going to try and put them in the right order. So we have fast evaporating solvents that you would use in colder temperatures. Mm-hmm. Now, in our infinite wisdom, our numbering system is completely skewed, but T2 is the fastest solvent we have. It evaporates really quickly. And we've got some videos coming up shortly on this to show the effect of the solvent. So T2 evaporates really quickly. T3 is probably the one that most people know and love. That's your middle of the road. That's your bench line. That's the one that you use, that the standard paint conditions, say 21, 23 degrees, something like that. That's the one that sort of sits in the middle there. Then you've got T5, which is the hot weather reducer, one that a lot of people are scared of. We all like to blame the reducer or weather conditions for runs and sags, or I like to call them flow indicators. But it's probably down to us a little bit in application, understanding what we've got. So I don't know. So hit me with a weather condition, and then we'll talk through a solvent choice or what you might do.
Okay. Low temperature, low relative humidity.
Okay. Well, that's interesting. So you've picked a nasty one. Okay. So low relative humidity means the paint dries quite quickly. If I say the term lacquer dry, it's where the surface sort of skins over and it sits there. And of course, that's not allowing your paint to flow out. So low humidity, you actually want a slower reducer because you want the paint to stay open for longer and flow.
Mm-hmm.
Hope I'm making sense. And then, but with your low temperature, of course, you don't want a really slow solvent because it's open for so long. You don't want runs and sags in it to collect sort of dust from the atmosphere. So you want a fast solvent. So actually, you've probably hit one straight there that maybe I'd consider a blend, you know. Thanks for making that one difficult, but maybe I'd consider a blend on that one. And it does it the other way as well. It does it with high humidity and high temperature because you want a slow reducer because of the high humidity. Sorry, let me get that right. You want a slow reducer because of the high temperature, but then because of the high humidity, you want a fast reducer because you want it to evaporate out of the atmosphere.
So, like this, I like this. It's actually quite good because I shot a little video on Q panels where I used the pipette to drop a little bit of the reducers on the panels just to see if we can visually see a difference as well. And that will be edited into this video now so we can go through it. The lower left, it's T2. No, is it? Should be.
It is.
T2. On the right bottom, it's T3.
Yep.
The right top, I have T2 and T5.
Yep.
And left top, you see T5. So what you're talking about then is if we blend it in those challenging conditions, they actually still keep their purpose. One evaporates quickly and the other stays on longer. And it's quite funny because this video will definitely tell you that.
Okay, so I think if you've done the pipette one, right, where you drop it onto the. Okay, so what people want to look for is you might need to sort of rewind the video, guys, and look at it again and concentrate on each square individually. But you'll see what happens is that the T2 evaporates the fastest. And on the opposite end of the spectrum, the T5 just sits there in a ball in the middle. The really interesting one, T3, as we say, is the sort of the intermediate, the one that sits in the middle, evaporates away eventually, but it's really good. It's the all-rounder. It's your Land Rover. That's only for English people, but it's your Land Rover of solvents. You know, it's your four-wheel drive, go anywhere, do anything.
Yeah.
But what you've got when you blend, and when we talk blend, by the way, use your opposite ends of the spectrum. You want the fastest and the slowest together. The further apart they are, the easier it is to blend and to make a difference, if that makes sense. It's almost like opposites attract. So that top right hand one that you're seeing on the screen, have a look at it. It as the solvent goes out, it flows out and then it becomes an egg. It looks like an egg. You've got the white of the egg and then the yolk, the yellow, comes into the middle. That's the T5. So it does both, Case. It gives you great atomization through the T2, fast evaporating, but then the T5 allows the paint to flow. So in those obscure weather conditions that you're talking about, where sometimes you want a slow solvent, but the opposite is happening because of the humidity or the temperature, is an example, then it gives you both. The important thing in all of this is probably not to use too much solvent. If you were painting something with, say, I don't know, let's go middle of the road solvent, and you're having to add, like 40% solvent to this this top coat to make it flow and do its thing, or feel good, consider changing or blending your solvent. You know, why do I need so much solvent in here? Well, I want to wet it out. And why are you struggling wetting it out? Is it too hot? Is the humidity different? So
Comes down to test plates basically again.
Yeah, in a way, so you can see the workability.
Make it work, yeah.
Yeah.
Then I have two more questions on this for this.
Okay.
Solvency power. The solvency power of the solvent.
Okay.
So the power it has to cut down the resin.
Okay, good question. So probably the faster ones, the faster reducers are the most aggressive. So they break down the resin, really break it up, and then really help with the atomization. So when you do those blends, that's what you want, because you want it really small, broken down, good atomization. But then you add the T5, the slower one, in there. So once it hits the surface, it post flows. Yeah. It's, you know, I don't think any of us would like 2.5 bar of pressure shoved into us. We're all going to feel a little bit of sensitive and disjointed with that. And what we want to do after we've had that high amount of pressure in us, we want to relax, right? And that's what's happening to the paint. You're firing it at the screen. Don't giggle. You're firing it at the screen, and or the panel, whatever you're painting. It's got all that pressure in it. Then you want it to post flow. You want it to relax and give you that great DOI.
But am I then correct in assuming that also the solvency power, if, for example, you would do 20% of T2 and 20% of T3 in your mix, that the readings in viscosity will be completely different?
Absolutely. I think as you start blending, then viscosity means less. And it's the same with temperature. You know, if the paint's cold, it's really viscous. If you warm it up, it will go through the din cup really quickly. But what people need to bear in mind, you need a minimum amount of solvent in that paint to make it work. You know, I'd say 15% is the least solvent you want in there for it to help the gun atomize, because I could get that paint so warm that it could run through the din cup in 12 seconds, and then people think, oh, I don't need a solvent, but you still do to a certain extent. So, you know, the din reading on the data sheets, you know, if you're sort of between 11.5 and 16 somewhere with your top coat, that's a gauge for me. And the reason everyone's going to come to me and say, Rich, on the data sheet it says 14 seconds, whatever it may say. But if you're blending and heating and doing all these crazy things to get the finish, then it's going to change the viscosity. So that 14 seconds becomes less relevant. But you as the painter make the decision, right? You've got all these choices, you've got the ways of making it better, but it's down to you as the individual as to how you do it. So from my point of view, I'd only suggest blending when you're really understanding your atmosphere and what you're doing. If you're in that climatically controlled booth at 23 degrees, can't go wrong with the middle of the road solvent. If you go into a hotter country, maybe you want to add a bit of slow. And when I say, you know, you can blend them 50-50 and then add them at your chosen reduction into the paint, you can add them 80-20. There's no hard and fast rule. You're never going to get a chart from me to say this humidity, this temperature, this is your exact mix. Doesn't work that way, but you'll learn it, right?
Well, maybe it's also good to point out to the viewers then that in each region we also have our white packs available, and if people want to reach out in order to test this kind of stuff, then we're open for it. Just
absolutely,
sales rep, and we'll make it happen.
I think the solvents cases, they're really interesting. We make so many, and paint manufacturers make so many because they have a job to do ultimately. So you can't expect one solvent to do all, depending where you go. I appreciate if you're in the same environment all the time. We might have some friends out there that work in a parts booth, you know, and it's always the same. Yeah. But when you're stepping out into different parts of the world, different atmospheres, we didn't touch on what makes the solvent evaporate so quickly. Everyone's thinking temperature. No, you know, air's volume, air over the top. you blow on top of the solvent on those samples that we've just shown, it evaporates really quickly. Airflow has a huge difference. So airflow, humidity, and temperature all have an effect on. Yeah, absolutely.
I think we got it covered. Is there anything you want to add to this?
No, I don't think so. I mean, if that's covered it, I mean, it's a pretty loose talk on solvents. As I say, I can't draw you a lovely little, relative humidity, temperature, draw a line. These are the solvents you want.
We like to close down this video. If you, as a viewer, have any kind of particular subject you would like us to talk about during the next video, please leave it in the comments. And otherwise, we hope to see you soon again. Thanks, Rich.
Thanks. Don't forget to follow us on social media, and we'll catch you on the next one. Cheers, guys.
Cheers. Bye.